Right, hello, my little friends, and I hope that you're all getting on well and life is treating you well. Let's check that this recording is on. Yes, it is good. And you managed to do last week's lab and everything acceptably in these unprecedented times. I don't think it was too taxing, so everything's good. And today in programming with object, next week what I'll do is I'll have a sort of engagement meeting, Teams meeting with all of the first years. To make sure that you're all getting on okay and to sort of do a check-in as well and to make sure everything's sort of running smoothly and everyone knows what they're doing in the correct modules and all that sort of thing. But today in Programming with Objects, we're on lecture 4 and we're going to be looking at algorithms, truth, flow control, which is sort of done through if statements, if else statements, switch, random number generation as well. So in order to sort of do the labs today, we'll have a look at that. So what have we done so far? We've had a look at variables in terms of variables having a type, a name, a value. We've looked at input and output, so converting strings to different types. So that's the console.readline takes in a string, and to perform mathematical operations, then they have to be converted to the correct format. So things like integer, double, or float in performing mathematical calculations. We've also looked at, these were the little exercises at the end of last week's lab, and hopefully you managed to sort of decipher how to do these. So conversion of Fahrenheit to centigrade. So you're calculating the centigrade by inputting the Fahrenheit, and that's how it's sort of done there. So temperature in Fahrenheit minus 32 in brackets times 5 divided by 9. The area and volume of a circle, and the calculation of the BMI. So those are the sort of formulas that I provided for you last week. And all you were really doing was inputting a value, performing that calculation and outputting a value. So the BMI is in fact a little sort of submission thing. I think it's about 5% or something, and you can put that on Aula in order to start getting some grades associated with the module. Okay. Now, when you're testing these little programs, so for example the Fahrenheit to centigrade, that's relatively easy. 212 degrees Fahrenheit is 100 degrees centigrade. So I mean, if you input these things, it's a sort of appropriate test. It's not lecture 3, it's lecture 4, drat. Okay, so it's algorithms, statements, blocks we're looking at today, decision making and program control, truth as well. So if statements is really covered in chapter 10 of the book. Switch statements is chapter 11, an entire chapter on them, my goodness. And random number generation. What I sort of mean by that is rolling dice, for example. That's how you sort of generate a random number, or rolling a die. I think a die is singular, dice is perhaps plural, I can't remember. But anyway, that's a sort of example. If you have to roll a dice or a set of dice, then you get a number between 1 and 12. And we'll show you how to sort of do that today as well. So that's the book there. And today we're looking at algorithms now. An algorithm is a sort of step-by-step instruction to solving a problem. Now, it's really the basis of computer programs, technical instruction manuals as well, and really it's supposed to require no intelligence to more or less perform an algorithm. So we've all been at the mercy of algorithms in our lives before. Perhaps you've ordered something from IKEA, you bought something from IKEA, and you're supposed to go through a sort of set of instructions in order to build something, and that always works well for people. So it's step 1, step 2, nuclear reactor, and you're supposed to have a nice set of instructions that anyone can follow, and it never works out that way. And it's the same with recipes. You're supposed to have a list of ingredients, a set of instructions, and basically you're supposed to have a culinary delight at the end, and everything's supposed to work out brilliantly. And it requires no intelligence to follow, but do try it. Come up with a sort of gourmet meal or something and see how well that works out for you. Trying to multitask and everything, I always sort of end up like Mrs. Doubtfire, setting myself on fire and all that sort of thing. So despite the fact that it requires no intelligence, multitasking sort of does in real life. So basically, it's a finite number of steps. Luckily, when it sort of comes to computer coding, it's a little bit more simplistic, perhaps. The steps are more sort of defined, shall we say. So there's a finite number of steps. We must reach a goal, and there's many standard algorithms for sort of common tasks. So usually maths and computing, perhaps. So I mean, if you consider mathematical exams or whatever that you've sat in the past, you have a formula perhaps given to you. You don't require much intelligence to actually apply that, but you just sort of follow it, fire in the numbers or the values that you're provided with, and apply it. And it really requires no real intelligence, and it requires you to not really particularly know where that algorithm sort of came from in the beginning. At least that's what you say in theory, but one of the sort of most complicated algorithms I've ever had to come up with was a mapping algorithm. I was designing an entity relationship editor and schema generator, so I had a sort of diagram which was nice to represent a database system, and then I was supposed to click this button. It was supposed to generate the relational schema, and that was a very, very complicated mapping algorithm that I had to come up with. So we're starting off quite nice and simply, and then you will, during the sort of course of the course and degree, and in your career as well, come up with incredibly complicated algorithms that require you to sit there and really put things on paper. And structure it all out and make sure you know exactly what's happening. So for that, I mean, I had to sort of look at the different relationships. So inheritance had to be brought into account, what kind of inheritance relationship it was, whether it was a one-to-one relationship between entities, whether it was a one-to-many, many-to-many. It was very, very complex. And presumably you guys will be doing sort of the same thing eventually. So if you think about possibly removing a node from a binary tree, you have an algorithm to sort of do that, but also it becomes more complicated because that requires a recursive algorithm that then calls itself, and you're going, oh God, I've gone cross-eyed. But before we actually sort of get into that, we'll look at simplistic algorithms. So they're named after an Iranian mathematician called, I don't know if this is going to be the correct pronunciation, Al-Khwarizmi algebra. Al-Khwarizmi algebra. Yes, that will go for. So an Iranian mathematician, look him up, and he was kicking about around about circa 500 AD. Good stuff. So that's an algorithm definition. It's a noun, and of course the plural is algorithms. And basically it's a set of instructions to be followed in calculations or other problem-solving operations to prescriptively describe the sequence of events that happens in order for you to reach that particular goal, especially by a computer. So that's why it sort of comes into play with you guys. So in terms of looking at converting Fahrenheit to Celsius, we take the number of degrees in the Fahrenheit scale, we subtract by 32, we divide by the number 9, we multiply by 5, and the result should be in the Celsius or centigrade scale. And none of these steps take any particular special skill or ability. A £2 calculator can in fact do the arithmetic under the direction of a human. And that all works well in theory, of course, until you've actually got to practically do it. Humans are scatty, they get distracted, that's why we always burn things like the toast. And toast should be very, very easy. Whereas I always sort of, when you consider recipes, I always arrogantly say, cooking is not rocket science. There's a set of instructions. It's cool. And then I try it and I think, oh God, I've screwed this up so monumentally, it's beyond belief. I always end up setting things on fire, burning things aren't ready at the right time, that sort of thing. So multitasking is not a male's strong point, put it that way. So other algorithms, not so simple, of course, and mostly algorithms are simple representations of what you do to complete a task. So when you're actually writing these things, there are various sort of ways that you can represent it and make it easier for yourself. So you're trying to do it in a clear, concise, unambiguous way. So obscure language is not a good idea. Neither is plain English, really. And most programmers look at program design language or pseudocode. And we will look at that in a moment. We can also do diagrams. When you're actually removing nodes from data structures and things like that, diagrams are more or less sort of essential. Data flow diagrams, and then of course, once you become advanced enough, you can just fire this straight into the coding window, because your visual representation skills should be so advanced by that point, you'll be able to just visualize it and go for it. Just see it in your head and type it in like a child prodigy in Lawnmower Man 2 Beyond Cyberspace. Like that sort of thing. Okay, most professional programmers use sort of program design language at an early stage and move into the programming language. Okay, so there's a sort of pseudocode there. You input the Fahrenheit, you do the calculation, you output the Celsius, okay? Here's another sort of representation. You got a flow chart, you start, you input the Fahrenheit, you perform the calculation, you output the Celsius. Yeah? And there, oh, dear, flew by. And there we are, we actually have the code here, okay? So you can sort of get to an advanced level where you're saying, I'm just inputting the Fahrenheit. So you ask for the input of the Fahrenheit, you convert that, you take that in as a string, you convert that to particular, what's it going to be, variable up above here. It must have been set to a double, as you can see. And then you get temperature, you've got the calculation to get the temperature in Celsius, and then you can output it in a very, very sort of nice way. So that's the sort of answer to that program I asked you to sort of do last week. So the answers, the solutions come in dribs and drabs, so you've got to sort of pay attention, like little breadcrumbs. Okay? So statements and sequences, fundamental rule of programming. In the absence of any structure, a sequence of statements really gets executed in the order that they appear. Okay? So there's a sort of example there. So the area of the top equals the width times the depth, the area of the side equals the height times the depth, the area of the front equals the width times the height, and the total area is the 2 times area top plus area side plus area front in brackets, okay? Another order of execution might actually produce the wrong result, so you've got to be sort of mindful of that. So blocks, a group of sort of single statements can be combined to form an unbreakable sequence, so these blocks are essential to structured programming. Now you'll notice that these are contained in little curly brackets. Now, when you sort of start, a rookie mistake is to have too many curly brackets of one kind and not enough of another. So, I mean, when actually designing a block, you should have the inward and outward sort of facing curly bracket immediately in there in the coding window, and then you put in your code, and that's the way it sort of works. Okay. An empty block, a block is not really required to contain any statement, so you get an example of a sort of empty block as well. It's unusual, of course, as it would normally include at least sort of one statement. So when we're talking about truth, let's look at that. Previously we've looked at only sort of linear programs, so to create interesting games and things like that, we've got to execute or skip certain parts depending on particular conditions, and that's evaluated to basically true or false, so Boolean values, okay? So for C#, the truth is either black or white, yes or no, 1 or 0, and true and false are really stored as Boolean values, and this is a very, very handy way of determining what particular pieces of code are executed and what particular pieces of code are skipped. So you've got Boolean values, the fact is equal true, the fiction equals false, okay? And that means that comparisons can in fact be made. So program control can be asserted. We're only sort of looking at linear ones at the moment, or previously, and to create, I don't know why I'm repeating this again, but to create an interesting game we've got to skip certain parts. So to test true or false and evaluate these things, that's me possibly belabouring the point, or I've got lost. So let's have a look at Boolean expressions. You get integer score here, integer target score equals 100. The score is assigned to 100. The score is then assigned to 50. And then if you say the score is greater than the target score, that equates to a Boolean expression. And obviously this is either going to be true or false. And is the score at that particular point greater than the target score? No, it's going to be false. Okay. So then we have relational operators in order to make these, to evaluate these things to either true or false. So you have equal to, which is 2 assignment operators side by side. You have not equal to, so that's an exclamation mark with an assignment operator. Greater than, you've seen this from sort of secondary education maths, perhaps, from even maybe primary, I don't know. less than, greater than or equal to, or less than or equal to. And these can be evaluated to some Boolean value, whether that's going to be true or false. So if we look at that, 2 is in fact equal to 2, that's going to be true. 2 is in fact equal to 7, that's going to be false. 2 is not equal to 8, that's going to be true. 2 is not equal to 6, that's in fact going to be true as well. So I've made a mistake there, sorry. 6 is greater than 2, which is true. 6 is greater than 9, which is false. 2 is less than 5, which is true. 6 is less than 5, which is false. And so on and so forth. So that's how you sort of do it. And remember that the single equal sign is already used as an assignment operator, so be careful of that, okay?
So the if statement, let's have a look at the if statement. This is to test if an expression is true and then execute the code that's based on it. So if you've got an expression contained within this if statement and that equates to being true, the next statement in the program will of course be executed, or the block of statements depending on what you're actually wanting to do. So let's have a look at this. If your age is less than 18, then no beer for you, yes? So that will just sort of go to that one. So this is an else statement as well. Or if you're in fact older than 18, would you like a lime with that? Yes? So you actually get beer. Unless we're living in these times, in which case no drink at all, no bars, no restaurants, no socialising, no life basically. So there's a sort of if statement example there. So if that's clear to everyone, hopefully. If age is less than 18, you get no beer. And else, age is greater than 18, would you like a lime with that? Okay. So the statement directly under the if statement is executed. But if this is a block of code, then it has to be sort of put in a block. Okay. So if that's true, and you can in fact set a sort of infinite sort of loop like that if you wish, while true, you can do that with while loops, which we'll discuss later on, then this is always displayed. Okay, so you can fire these into the coding window and see exactly what you get. If score is equal to 1,000, two assignment operators there, then you've got to put these two things in a block in order for them to be executed, okay? So you get flawless victory, impressive, yes? So have a look at that. You don't use a semicolon after the closing parentheses of an expression. I'm not really sure, this is a C++ example, and I'm not really sure how C# actually copes with this, but essentially the semicolon is a statement terminator, okay? So if false, and then you put a semicolon after that by some accident, the compiler in C++ won't see any problem with it, but it won't actually execute this next line of code, yeah? So basically that's what happens there. It's an empty statement, and that is never actually displayed. It's an easy error to make, and it won't produce a compiler error in C++ anyway, okay? So get Admiral Akbar there. It's a trap! Oh God, I miss you guys. I miss interacting with students, I've got to say, because at least now I make myself laugh. It's a trap! Good stuff. Right! Do not confuse the assignment operator with the equal to relational operator. Be very, very careful of that. And if you do it, this is what sort of happens. So you get an integer score is assigned to 500. So get used to sort of reading code like that in your brain. Integer score is assigned to 500. If score is then assigned to 1000, then you scored a perfect score. And you've sort of done it anyway because you've assigned it. You haven't actually done an equal to comparison. Easy error to make. Once again, will not produce a compiler error, and it's difficult to actually see. So it's a trap! Excellent. Okay. So you're testing if an expression is true and then executing the code sort of based on it. So that's the sort of summary there. Okay? Go back to that. True statement executed. Okay, block of statements executed. Right?
Right, to test if an expression is true and then execute the code based on it, as I've said before in the previous slide. So here's an example. If score is greater than the target score, then you win. And if score is greater than the target score, if you're wanting to put that into a sort of block, the game finished can be equal to true, and you also sort of win. So that's a sort of block, okay? So here's a diagrammatic representation of the if statement. This will be in your class test, I believe. So you start, you've got a condition, either that condition is going to be true and the code is going to be executed, or you're going to skip that code because it's false and you're going to the end of the code block. Okay. You also have nested if statements as well. So you can do that sort of thing. So if score is greater than 500, you scored at least 500. And then what happens if your score is greater than or equal to 1,000? You scored 1,000 or more. Okay? So you can kind of do nested if statements as well. So what happens if the score is 250, 750, 1,250? You can then implement that and try these things. Obviously, there are other ways as well. So if else, here's an example here. This is when the if and the else part is used if there are different conditions to perform when the condition is true and when it's false. Okay? So here's an example. If mark is greater than or equal to the pass mark, then the pass becomes equal to true. The credits for a module at UWS then jumps up by 20. Else, the pass is equal to false. Or the pass is equal to false, and you've got to sort of enroll for a reset. So that's actually calling another sort of procedure there, but it's just an example, okay? So here's an example of the structural, sort of structural representation, diagrammatic representation of an if-else statement. So you're starting, if the condition is true, then execute the block of code here, and if it's not, then execute this block of code, and then execute the outside code, outside the code outside of the block. Yeah. So you get if, else if, and you can string together any number of if, else if statements to get a multi-way selection. So there we've got a sort of example there, and it's please enter a value. Then if value is equal to 0, the value is 0. Else if the value is a modulus of 2 is equal to 0, the value is even. And if not, the value is odd. Okay, so you can sort of link these things together. Okay, so if, else if, else. Yeah, so file that into the coding window and sort of see what you get. Okay. So once an if-else condition is reached, that is true, no other ifs or else parts are evaluated or executed. So the code below outputs value 5, less than 5, and does not value output value at less than 10, even though this is also sort of true. So this is what we're sort of talking about here. Okay. So have a look at that. So once an elf, I'm obsessed with Christmas right now. Once an else if condition is reached, that's true, then none of the rest of the else ifs are then evaluated. Okay? So hopefully that makes sense. If I can get elves out of my mind. Okay, so we'll get logical operators, and these can be used to combine conditions accordingly to the rules of sort of Boolean logic as well. So you get condition A and condition B. Then you get two ampersands, which represent and in programming languages, or you've got or, which is sort of two lines, okay? And then you've got the not, okay? So you can co-join these things. There is a sort of operator precedence, and that is not, and then or, okay? And that's to evaluate an expression, okay? First use brackets as well, if you're putting a great big expression in there. So condition A, condition B, if these two conditions are true, then that is going to be equal to true. If one of these conditions is true, then that's going to be equal to true, okay? In this particular case, both of the conditions is not equal to true, so that's false, yes? False and false, okay? So you can see the way that that sort of evaluates, okay? Or's very, very different. One of them is true, therefore the statement is true. Okay? That's the and that's the or. Okay? The not, if condition x is true and you're then evaluating that to not, then that's going to be equal to false, and that is going to be the exact opposite, if that makes sense. Okay? The example, there we have x is greater than 5 and x is less than 10. Okay? So see how those things are in fact evaluated. So enter that into the coding window, try 3, try 7, try 12, okay, to see how it actually evaluates. And that's relatively easy. It won't equate to true the first time, it will equate to true the second, and it will not equate to true the third time. Okay? Then you've got other things like height. Age is less than 16, or height is less than 1.75. So try these different things, you can input these and see what you sort of get, and it should be relatively self-explanatory. Okay. Compound conditions, two possible approaches. You can do a sort of nested if statement. So in terms of driving license, if your age is greater than or equal to 17, and you have a current driving license, and you haven't been banned, then you're a potential driver, okay? Or you can use logical operators in order to make that sort of work as well. So that's the sort of equivalent here, using logical operators. So you can either use the nested if statements or the logical operators, okay? So if age is greater than or equal to 17, and you have a license, and you've not been banned at all, then you're a potential driver. So it depends on what particular way that you're wanting to do it. Okay? So do think about that. I think these are a bit easier, to be honest. Nested if statements tend to be a bit of a pain. Okay? Then you've got the switch statements. These are very, very good for coming up with menus and things like that. So can be used to create multiple branching points in the code. So if you have a particular case where you put in a choice and that is going to be the value 1, then you execute this statement and then you've got to break, or you execute that statement depending on whether it's value 2 or value n, and you can have as many of these as you want. And it's also very, very good for error checking, because you can have a default at the end which then indicates a bad choice. So essentially that's very, very good for error checking and making sure that you don't input a bad choice. Okay. So the choice can in fact be an integer, a string, or a boolean. Okay. I don't really know what's happened to my switch statement there. It must be because it's not really sort of come out. But anyway, sorry, I don't understand why that's not appearing. But here is another sort of diagrammatic representation of a switch statement. So you've got your expression, case 1, you're going to your statement, that's the value that you've entered, and then you break, yeah, case 2, case n, as many as you want. Brilliant for constructing menus as well, and then there's a sort of default as well. Okay. So I've said that, excellent for implementing menu structures. So it can be int, string, or boolean. So there we go. Choice 1 in the menu, choice 2 in the menu, not a menu choice. You can have as many choices as you want, and you can see why that would be, we'll discuss it later, but why that would be excellent for implementing sort of menu choices. Okay, so random number generation. In games, unpredictability can be really more or less equal and equate to excitement. So enemies appearing randomly. There's a sort of Silent Hills demo that was cancelled, but sudden changes of where the horrible ghostly character in fact appeared. That was done through sort of random number generation. So in the lab you've got a sort of random number generation thing today. So this is how you actually come up with a sort of random, you've got to instantiate a random object, yeah, and that's fine. So that's how you do that, that's the line of code to actually use the random object. And then you've got to more or less fabricate that or put in the parameters, the range in the .next function. Okay, so the main thing to remember is that gives a random number 1 to 6 inclusive. So that fires back an integer or a random sort of integer. The .next generates a sort of random number, not as random as you might think, to be perfectly honest. So that's an integer dice value, and then you're trying to fire back a random digit, random integer within those particular parameters of 1 and 7. But that's inclusive. For some bizarre reason, it's going to be 1 and 7. So that will give you these sort of random numbers between 1 and 6. So do have a look at these. And you've got to sort of mess about with the numbers in order to get that right. So that's what it sort of looks like. You can have these characters just appearing at random locations if you want. So we've looked at control flow, if in fact I've been able to say it. So structured programming imposes rules in control flow. We've got the statements that are executed in order, and then you've got the selection statements in order to make those sorts of choices. And in the lab today, I have got a number of very, very sort of groovy exercises for you. And of course my computer has shut down at the moment. It's taking its sweet time to come back on. Yeah, there we go. So I've got the 8 exercises for you in the lab, and let's see, we have write a program which asks the user to input a temperature, and then depending on what they actually input, saying whether that's going to be a lovely day or what. You've got the BMI program as well, and that gets you to input a particular BMI or calculate a particular BMI, and then it more or less uses an if statement to assess whether people are underweight or overweight or obese or whatever, or healthy. And then there's a sort of grade example from UWS. And then there's a write a program which enters your mark, okay? And then there's a sort of wee kind of computer football game. So write a program which reads in the names of 2 teams, the number of goals they've scored in a game, and the program should output the winner, the name of the winner, output a draw, depending on the score as well. So that's a sort of if statement thing. Write a menu selection program that allows the user to enter a number to select from 3 game difficulty levels. So easy, normal and hard. Okay. And in a computer version of rock, paper, scissors, the computer needs to set a string dependent on the player choice of rock, paper, scissors, depending on whether they enter 1, 2 or 3. So use a switch statement for that. And then you can randomly generate the number of your opponent as well. So that's going to be quite interesting. And then there's a sort of exercise 8. So it's a sort of film thing. So the films shown below and their age ratings are based in a sort of local cinema, Cineworld. Oh God. Write a program that allows the user to select a film from the menu. So you're using a switch statement there. And enter their age, honestly, of course. The output should show whether the user is allowed to see the film with message, please buy your tickets, or whether they are too young, so that you can't buy your tickets. So that's the sort of groovy exercises that I've got for you today. So do try them yourself. It should take you quite a long while to sort of write all of those, maybe over a period of 2 weeks perhaps. I'll check in with everyone next week to make sure that they're getting on okay. And if not, I mean, the solutions do eventually become available at some stage after I think that people have suffered enough, and we'll see how people sort of get on with it. Do try them yourself, because it is quite nice to be able to say I didn't manage to get the solution or a solution myself without the answers just simply being provided. But anyway, I shall put them on the Owler system as well. And I'll have a check-in session with you all next week. We'll possibly do it on the Thursday. Okay, right. Okay, see you later. Bye-bye.